Good afternoon, sir. I am Sushmita Kudodgi from 8th SEM Electronics and Communication Department. Today I am going to give a seminar presentation on biobattery under the guidance of Professor Praveen Guru. Contents are Introduction, what is biobattery, history, working of biobattery, need of biobattery, types of biobattery, future scope, advantages, disadvantages, applications, and conclusion. Introduction. A biobattery is an energy storing device that is powered by organic components. Biobattery can also be called as an energy accumulator device that is motorized by organic compounds, usually being glucose in human blood. Many electrons and protons are released due to a breakdown of glucose by enzymes present in our body. Thus, the batteries directly get energy from glucose by using enzymes present in our body break down glucose. An interesting fact is that bacteria can generate electricity when a protein in their cell membranes get in touch with the mineral surface. What is biobattery? Biobattery is a device known as which is the substrate material, organic or inorganic, which is converted into electrical energy. History. As an electrical signal can induce a biological reaction, the reverse in is also true in most of the cases, and in this way, biological processes can be used to generate electricity for powering electrical equipment. Even though the biofuel cells have been known for almost century since the first microbial BFC was demonstrated in 1912. The first enzyme-based biofuel cell was reported only in 1964 using glucose oxidase as the anodic catalyst and glucose as biofuel. Construction of biobattery. The construction of biobattery can be done by using four components such as anode, cathode, electrolyte and separator. All these four components are coated on each other so they stack up jointly. Similar to other batteries, in these batteries the anode is negatively charged as well as the cathode is positively charged. The main difference between the anode and cathode permits the flow of electrons inside and away from them. In a biobattery construction, the anode terminal is placed at the top of the battery, whereas the cathode terminal is placed at the bottom of the battery. In between these two terminals, electrolyte is placed, which includes a separator. Here, separator plays a key role by separating the anode and cathode terminals from one another, which can be lead to avoid the short circuit, otherwise the entire battery will damage. In the system, the electricity will be generated by flow of electrons as well as protons. Working of biobattery. A biobattery generates electricity from carbohydrates, utilizing enzymes as a catalyst. Through the application of power generation principles found in living organisms, the biobattery incorporates an anode consisting of sugar digesting enzymes and mediator, and a cathode comprising oxygen reducing enzymes and mediator, either side of a cell phone separator. The anode extracts electron and hydrogen ions from the sugar through enzymatic oxidation, which is as follows: glucose is equal to glucolactone plus 2H plus 2 electron. The system uses the flow of electron as well as the proton for generating electricity. The proton movement can be occurred due to the moment force, which is known as current. The electron flow can be from anode to cathode, whereas the current flow can be from cathode to anode. The biobattery working operation is here. The glucose is used at the anode side, whereas the enzyme is used at the cathode side. Glucose gets broken down into electrons and protons. The flow of proton can be traveled to cathode side via a separator, and the flow of electron can be traveled to a cathode via mediator. Enzymes are utilized at cathode side, which generates water by both proton as well as electron traveled from anode side. Here the need of biobattery. In the field of electricity, a battery is a device that converts chemical energy into electrical energy. Different types of battery are used in various electronic and electrical devices. However, these batteries contain certain chemicals such as compounds of lead and mercury. which are highly toxic in nature. Therefore, biobatteries have a great potential to be used as a suitable alternatives or even replacement for chemical batteries in the future. Types of biobattery. Enzymatic biobattery. In this type of biobattery, biochemical agents which are enzymes are utilized for a breakdown of substrate. Microbial biobattery. In this type of biobattery, microorganisms such as Escherichia, Escherichia coli, electric bacteria are utilized for breakdown of a substrate. Future scope. Biobatteries have a very bright future ahead of them as test productions and research have been increasing over recent years. They serve as a new form of energy that proving to be environmentally friendly as well as successful in the producing and reserving energy. The advantages of biobattery: quick recharging capabilities, eco-friendly, clean and non-toxic source of energy, raw material available easily and plenty, extremely safe, portable and lightweight compared to fuel cell. Disadvantages: compared to conventional batteries such as lithium batteries and biobatteries are less likely to retain most of their energy. This causes a problem when it comes to a long-term usage and storage of energy for these batteries. The applications are electronic devices, medicine, defense purpose, fuel synthesis. The conclusion is the biobatteries are high performing, stable, and reproducible enzymatic fuel cell technology developed over last 5 years. The scaled up demonstration of biobattery powering electronic circuit, which is performed at both power sources and Army Science conferences. Thank you.